Let's explore big data architecture patterns. We will discuss common architectural patterns for designing scalable big data solutions. Big data architecture is a blueprint for organizing and processing massive data sets that traditional systems cannot handle efficiently. Key point number 1 is volume. Big data deals with petabytes of data. Key point number 2 is velocity, emphasizing real-time processing. Key point number 3 is variety, addressing both structured and unstructured data. Key point number 4 is scalability, focusing on horizontal growth to accommodate increasing data volumes. The Lambda architecture pattern combines batch and real-time processing to handle both historical and streaming data. The first layer is the batch layer, which focuses on historical data processing. The second layer is the speed layer, which deals with real-time stream processing. The third layer is the serving layer, which provides a query interface for accessing the processed data. Data flows from a raw data stream through both batch and speed processing layers before being unified into a single view. The Kappa architecture pattern is a simplified approach using stream processing only for both real-time and historical data. One benefit of this architecture is the single processing paradigm it provides. Another benefit is reduced complexity compared to other architectures. The final benefit is easier maintenance. In this architecture, all data is treated as streams, which are then processed by a stream processing engine to produce real-time results. There is one path for all the data. The microservices architecture pattern involves breaking down monolithic applications into small, independent services. Each microservice can be deployed independently. Each microservice uses service-specific databases. The microservices communicate through Application Programming Interface or API-based communication. There is technology diversity within each microservice. The architecture involves decomposing the application into services such as a user service, a data service, an analytics service, and a storage service, all accessed through an API gateway. In the event-driven architecture pattern, components communicate through events, enabling loose coupling and scalability. The characteristics include asynchronous communication. The components are loosely coupled. It gives real-time responsiveness. It gives high scalability. The architecture follows a publish-subscribe pattern, where a producer sends events to an event bus, which then distributes them to consumers. The data lake architecture pattern uses a centralized repository storing raw data in its native format until needed. This architecture uses a schema-on-read approach. It supports multiple data formats. It is cost-effective for storage. It provides flexible data exploration. The data lake consists of 3 layers: raw data ingestion, data processing, and analytics and machine learning. The data mesh architecture pattern is a decentralized data architecture, treating data as products owned by domains. It has 4 principles. The first one is domain ownership. The second one is data as a product. The third one is a self-serve platform. The fourth one is federated governance. The architecture distributes data ownership across domains such as sales, marketing, finance, and operations, with federated governance ensuring interoperability. It's an interconnected data product. The polyglot persistence pattern involves using different databases optimized for specific data types and use cases. This architecture gives optimized performance. It gives the right tool for the job. It gives better scalability. It gives technology flexibility. Different types of databases are used. SQL database for relational data. NoSQL database for document store. Graph database for relationships. Time series database for metrics and events. Choosing the right pattern requires careful consideration of several key factors. The first factor is data volume and velocity. The second factor is latency requirements. The third factor is team expertise. The fourth factor is budget constraints. The fifth factor is future scalability needs. Some of the patterns available are Lambda, which is a hybrid batch real-time processing. Kappa, which is a stream-first approach. Microservices, which is a service decomposition. Event-driven, which gives loose coupling. Data lake, which has flexible storage. Data mesh, which gives domain ownership. Remember, no single pattern fits all scenarios. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.